Okay, so if you were to look at flashcard number 5B, it gives you PVA. And specifically, flashcard number 10B is going to give you the velocity is the what value of the what? Absolute value. So let's see. We have our total distance is the absolute value from the lower to upper bound of the velocity. So the given information is 6t minus t squared. So I need to go up to the particle, okay? Now, to go up to the particle, that's the integral of it. So if I integrate this, it's going to go up to the particle. So let's all write on here. We have integral of 6t minus t squared dt. And let's kind of recall integrating. What do I do to my current power? Add one more, and then divide it by that number. And then we have minus, add one more to that one, over 1/3. Oh. And then we're calculating from 0 to 3, because that was a time 0 to time 3. And let's actually plug it in. And before we do, let's simplify this. That alone is going to give me 3t squared minus 1/3 t cubed at the value 0 to 3. Okay, let's plug in the 3. We have 3 times 3 squared minus 1/3 times 3 cubed. Do I even care about plugging in the minus 0? If I plug in my 0, it's going to end up 0, right? So let's not waste time on that one. So Rohan, what is all of this going to give us?
6.
Oh, 3 squared.
9.
Where are we looking?
Well, that's 27.
That's 27. And then the next one is going to be 9, right? So 27 minus 9 is 18. Which answer choice are we looking at? D it is. So tally yourself. Was that a potential or was that a raw? Okay, let's go on to number 7. That's the basic of the integral. Please don't miss that. All right. The next one, I'm not going to have y'all read it because really in the end it's chain rule. Okay, let's kind of recall chain rule. What do I do to my outside power? Bring it to the front and keep the inside exactly as it is. And then it becomes one less power, which is how many? 4. And then we derive the inside. Okay, Charlie, what's the derivative of x cubed? What is the derivative of x cubed? 3x squared.
We got this answer right.
Tell me you knew that.
We got this answer
Okay.
right. I got that answer.
And then when I derive the cosine,
He's tired, miss.
he's tired. When I derive the cosine, it is negative, but since I already have another negative existing, what sign do I need?
Positive.
Good, plus sign of x. And again, these are freebies. Do not miss it. And that answer choice is going to match which one? E it is. So again, tally, is it a potential? Did you get it for the raw score? Okay, my next one. Emily, let's read number 8.
The tank contains 50 liters of oil at time t equals 4 hours. Oil is being pumped into the tank at a rate RT, where RT is measured in liters per hour and T is measured in hours. Selected values of RT are given in the table above. Using a Wright-Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at time t equals 15 hours?
All right, so for this one, we're using the left Riemann sum and, right Riemann sum, and we have 3 loops. Let's all make our 3 loops. So within that, what's on my right side? 6.5 or 6.2? 6.2. Between 4 to 7, my difference is 3. Now between 6.2 and 5.9, my right side is 5.9. What is the difference between 7 and 12? 5. My next value is going to be plus 5.6. And then we have the difference between 12 and 15 is 3. So 6.2 times 3. Quinn, how many is that?
18.6.
Thank you, Quinn. The next one. Ned, what about 5.9 times 5? 29.5. Okay, Kendall, what do we get for 5.6 plus 3? I mean, times 3.
16.8.
Good job. Let's go ahead and add all of them.
Run all you do.
Emily, let me know once you add all of them.
And you know,
Chill.
we're losing time. We need this for FRQ. It's like,
Kendall, be nice.
Oh, wait, are we? 10, 18.
Some 2 digits and a decimal, right? 64.9. Now here is a common mistake. A lot of kids get to that and go, hey, I got my answer.
You have to add 50.
But we have to add the initial. What was the initial?
50.
50 liters. You have to add the 50, which ends up being which one, Max?
C.
C it is. So go ahead and score your raw and potential for that specific problem. Okay, my next one. Frank, let's read number 9.
Let x be the function defined above. To what value of k is that continuous at x equals 2?
So let's kind of recall continuity. My limit must match the point. So right now, k and 2 is my point, correct? 2 comma k. So I need to match the limit of the original equation or the function. So let's write on here we have the limit as x approaches to 2. Everyone's writing, especially if you didn't get to this one. This could only be hard if you're not remembering the continuity definition. But as long as you know it, the point must match the limit, you're pretty much good to go. What can I cross off on the top and the bottom?
X minus 2.
X minus 2.
And that means X is approaching.
And then we have, that's going to be how many? It'll be 2 times my x value that we're approaching is 2 plus 1. How many is that value? 5. And E. And I know normally I have you plug it in and you'll get 0 over 0. And then that's a do more piece. But at this point, I think we're pretty much way beyond that point. All right, Charlie, read number 10, last one.
What is the area of the region in the first quadrant bounded by the graph of y equals e x cubed squared divided by x equals 2?
That's okay.
Can you repeat that?
No, don't. Charlie, you're good. I didn't realize. Okay, that's my fault. Okay, let's do a little quick sketch. When I do a sketch, y'all do know e to the power of any x is always exponential, right? So for my exponential, I'm only sketching. It's not going to be perfect. And then x equals 2 is right here. I'm going to use my highlighter just because that's the way I taught it for Unit 7. So here's my top, and then here's my bottom. So to connect the top and the bottom continuously, do I need a horizontal rectangle or a vertical rectangle? Vertical. So then, I want you to get your arm out vertically, everybody. If I'm scanning vertically this way, from left to right, that is with respect to what? Very good. So we have with respect to x. I know you didn't need that part, but why not? So it's going to be top minus the bottom. Now, when I do top minus the bottom, do I care about the bottom being 0? Do I need that information? It's just going to be top portion. So let's put on here, we have the integral from 0 to 2 of e to the, I'm going to write 1/2 x, just for teaching purpose. And we do have to use u substitution. So here goes my u. Let's all write off to the side. U is equal to 1/2 x. du is 1/2 dx. Am I looking for 1/2 dx or just dx? Just dx. So multiply by 2 on both sides. Are we writing, girls in the back? Okay. Now let's do our substitution. Pull the 2 out. And I'm going to write e to the u du. But because I'm thinking ahead, I want to go ahead and convert everything in terms of u. So my initial one, my x was 2, and x was 0. So when I plug that in into this guy over here, Kendall, what's my new u value when x equals 2?
1.
Kendall?
It's 1.
1. And then Max, what about when x equals 0?
0.
0. So let's put that down instead. Plugging in 1 and 0 is very easy. So let's kind of recall. Derivative of e to the u is e to the u. Integral of e to the u is the same thing. So let's put 2 on here. I'm going to put a bracket. e to the u. Again, I do not have to convert anymore since I went from x to u. And let's plug them in. We have 2 e to the 1 minus e to the 0. What is e to the 0?
1.
So if I go ahead and distribute this guy over, it's going to give me 2e minus 2. Do we agree on that? Okay, which option do we have? A it is.